Okay, now back to page 3. And then this is one of those, just like we did on page 2, where it's kind of like a geometric proof, but not really. So, what would I do from this step to the next in order to get this problem solved? And actually, you would do this property, which would become this. And the answer to that, is the property is the distributive. It's called distribution. So this is a term that I will use when we actually solve equations frequently throughout this year. There's going to be a lot of that. Um, so that's called distributing that 7 through and then multiplying it 7 times x and then 7 times 1 for those that haven't seen it in a while. Next thing is, in order to solve, like I said before, solving an equation, the equal sign's like a balance. Whatever I do to one side, you do to the other. But these are both on the same side. So what you just do with those is add them together. And then this becomes minus 6 there. All right. That actually is just called combining like terms or simplifying. So combine like terms. So again, just using some terminology here, the fact of writing it will make you remember it more if you've not seen that in a while. Now we're going to talk about, okay, we have to get this equation solved. I always think of an equal sign as like a fulcrum. Whatever I do to one side of that balance, I better do the other, like I said before. So the next thing to get x by itself is to add 6. So this is the addition property of equations. Feel free to do that. I guess we can use little symbols if we want. And then the last thing is x equals 3. How? Because what I have to do to both sides is divide by 7. So this is the division property of equations, or of equalities, really what it really is called. All right, so I may have a silly little question on your next quiz that pertains to that. All right, now to something completely different. All right, kind of with some angle measures and seeing this little drawing here, and maybe using some of the thoughts that we did on page 1. First of all, know how to name an angle so you can label this. So, sorry, still got the cough. A to O to E is this opening. O is the vertex, so it would be smart to put a 50 degrees right there. All right, now they're also going to ask you for some measures. So name an angle supplementary. All right, so I guess we got to throw that term down. What does that mean? Supplementary means angles that add up to equal 180 degrees. So who would be supplementary to B, 2O, 2C? Well, now we're going to have to use that thought process. I'm going to erase this real quick that we used on page 1. Where what kind of angle is this? It starts with an S, and that's called a straight angle. So this adds up to 180 degrees. So if this is the angle that I'm looking at and who's supplementary to that, it's this one through the angle addition postulate. So the answer to that would be angle B to O to E, or you could switch B and E, but O must be in the middle. Because BOC is this one, and then to finish off the 180 degrees, I'd need this one. So this angle measure is from B to O to E, and that's how you would name it. So that would be that answer. Okay? All right, so I can erase that. Name an angle congruent. Congruent is almost like another word for equal. And adjacent. Adjacent means right next to or sharing a same side as AOB. So who is both congruent and adjacent to A to O to B? Well, A to O to B is this angle measure. Sorry for being sloppy with the pen. And this angle is 90 degrees. What's this measure from here to here? And the answer to that is 180, because this again is a straight angle. All right, so what does that mean this measure must be from here to here? The answer to that is, well, if this is 90, 90 plus 90 equals 180. So the angle that is supplementary and adjacent to AOB is BOD or DOB. All right, so, but O must be in the middle yet again there. So again, 90 degrees, this must be 90 because these add up to 180. These kind of questions, working with angle measures and knowing what, that all means. Name an angle complementary. Complementary means angles add up to equal 90 degrees. All right, so these are some terms from your, hopefully, vocab. All right, so C to O to D. Let's go back to red so we can see that. Angle COD is this angle. Now, we just went over that. If this is 90, this is 90. All right, so who is complementary? Almost said the wrong word. Complementary to this angle. This one right here. I'll change the colors. I tried. It didn't work. Okay. Oh, for the love of whatever you believe in. There we go. That angle finally had it happen. So it's angle B to O to C that is complementary. One quick trick. Who comes first, C or S in the alphabet? Good answer. You said C. Who comes first, 90 or 180? 90. So we should never confuse these two words. C comes first, 90 comes first. S comes second, 180 is second in that order. So complementary means add to 180. I'm sorry, add to 90. Supplementary means add to 180. Complementary 90, supplementary 180. Okay, now name a pair of vertical angles. I use that term twice on page 1. Let's get rid of that. A pair of vertical angles would be this pair. Straight line. Actually, all lines are straight. That's redundant. And then that's another line. These would be a pair of vertical angles directly across from each other. You actually have another pair, but I'm going to go ahead and name those. This angle, which is angle AOE, and then this angle, which is angle COD. And then we'll be able to use that information probably to find some measures. But another one is actually these angles all the way across are supplementary, ignoring this little side, getting rid of that in your mind for a second. So actually A to O to C is this big measure here, and that is vertical with this one, E to O to D. All right, so that would be another pair, ignoring that little side there that's listed. All right, now find the measure of E to O to B. All right, well, this is interesting. E to O to B, if I can grab my highlighter, I'll try again, and I'll go yellow. E to O to B is that measure. And you just got to do a little math on that. And the math is that this is 90 and this is 50. So again, that little thing that we used on page 1, the angle addition postulate, says that angle should be 90 plus 50, which is equal to 140. All right, so a little bit of basics of geometry, dealing with angle measures, what's going on here. Erase that. Oops, I want my 50 back because I bet you will need that maybe for the next question. Who knows? All right, so from B to O to C. This is a trick question here, because what it requires is that I do that vertical angle thing again. I keep missing. All right, there we go. So vertical angles. So what you know is when I highlight again, this is 50 degrees here because these are a vertical pair of angles. All right, so how does that help me find this? It goes back to what we talked about all the way through all of this. This, we already determined from a previous question, equals 90. So if this is 50, there's 40 left over. All right? So kind of built up all of that, asked some questions by getting some names of angles written down, what's true, but also actually getting measures. Okay, now to page 4, I think we're on. An attempt at drawing a 3-dimensional image on a 2-dimensional screen. So this represents the front of this. Okay, I'll use the word even though we'll use it in chapter 9. A rectangular prism is what this is called. So that's the front. So that makes AEFB the back panel. And then ACGE is the left. BDHF is the right. Top and bottom. Top is ABCD. Bottom is EFHG. All right? So what is the intersection of? Now we're talking about planes, and if we were in the classroom, I would use the room for this. So pretend this is our room, and we're sitting here, and then I'm up here trying to figure out how to work the technology. Okay, so you guys are sitting there, and then here's our room. So Now, planes. What is a plane? A plane is a flat surface. So on page 1 of our notes, we talked about lines and points and rays and all that other stuff. Now we're talking about planes, which is a flat surface like your piece of paper, like the table you write on, or like the walls of our extremely tall classroom. Here's the ceiling up here. Okay. All right. So who is CGH? Now planes, even though I illegally named the planes down here, you really just need 3 letters to determine a plane. So who is C to G to H? Well, CGH is actually the front. And then who is A to C to D? A to C to D is the top. So the question is, what is the intersection of these? Well, if you imagine we're in the room, I'd ask you, this is the front wall where I will teach eventually if I could get it to work. And then this is the ceiling. So what do they have in common? This little segment or line. So you have an option. I guess we could say CD the segment, but if we pretend that these planes go forever, then this would be a line where they intersect. And I guess I would allow either or on that, depending on how you look at things. But with that kind of being a closed room, we'll probably just call it a segment right now. All right, name another point in the plane consisting of, let's erase us, A, C, and D. So A, C, and D, the fourth point that is in that same plane would actually be point B. And you just put that.